Okay, we're in passage 3. This is a research passage from 61C. That's the test. Remember the DRC approach to reading, since this is research, the DRC, this is the R. So you read, not carefully read, but you just read through it to understand the multiple studies or processes. You're not reading super carefully, but you're looking for the differences between the studies. Sometimes you're not going to need to read much. Other times you're going to ask questions about the differences between the studies. So this is passage 3, the passage you should be on. You know it as a research passage because it says experiment 1, experiment 2, and experiment 3. So you know they're comparing experiments. You can skim the intro if you want, and then go to the see the differences in the studies. So in this one, it looks like we're using electricity, electric circuit. And then we have time changes in voltage across the capacitor. So voltage is here, I guess. In experiment 2, capacitance changes, and then time to reach 6 volts is what we're looking at. In table 3, resistance changes, and time to reach 6 volts changes. So just the basic differences are the different things we're looking at. So less than a minute, you're to the questions. Our approach to the questions is the R and R approach. So you're going to read the question and then reread the question. So in your first reading, you're just trying to understand what it's asking, kind of orienting yourself, skimming, if you will. And then your reread, you're really breaking it down step by step. So as we go through it, I'm going to be doing the reread part. Already read it. Hopefully you've already read it and we're rereading. If you haven't read it before we start, pause the video and read it before we start. Your first read through, this is the question you're answering. The time constant of the circuit used in experiment 1 was. So now let's break down the question. In experiment 1, put your finger on experiment 1. The time constant, so words that are italicized are new information. Know that when you see that in a question, it's presenting something you haven't seen in the passage already. So the time constant is the time required for the voltage across the capacitor to reach 7.6 seconds. So let's find voltage across the capacitor. You see it as the second column in table 1. We want to know when does it reach 7.6 seconds. So we know it's before 12 seconds, so your answer has to be F. Okay, question 15. This is the question you're trying to answer. You go on your first read through. The time required for the voltage across the capacitor to reach 6 volts is closest to. So it's an if question. You got to think a little bit. You may not get an exact answer. So using experiment 2, put your finger on experiment 2. That second column has our time to reach 6 volts. It's where we're going to find our answers for the seconds. 1.5 times 10 to the negative 6 capacitor. That's the first column, and we can see it increases. So 1.5 is going to be above 1.2, the highest labeled capacity we have. And so let's look at the comparison here. So we go from 0.3 to 0.6, it doubles. So when we go from 1.2 to 2.4, we would expect it to be about 16.6. So probably less than 15, but greater than 8.3, so 10.5. So C. The main purpose of experiment 3, put your finger on experiment 3. Looking for the main purpose, so we can see, just looking at column 1, that they're looking at different resistors. So when we look at our questions, choice F and J both have resistors resistance in it. The second part, though, is the time to reach 6 volts across the capacitor. So they're looking for the time required for it to reach a set value, 6 volts, not a given time. So choice F is out. So your answer is J. So in your first read through for question 17, you want to know which of the following circuits should one use. So put your finger on figure 1, because based on figure 1, to measure the voltage across the resistor. So this is the resistor, so we can see that in each of the figures. And the voltage across is going to be measured by the voltmeter. So which one surrounds the resistor? That's going to be choice A. Question 18, your first read through, we're looking for the given value in the shortest amount of time for a circuit. So fingers on experiments 2 and 3. We'll start with the F first. You don't have to know what that stands for, just know where you're looking for that symbol. We're looking for the time across it to be the fastest, and it's 0.7. So that's at 0.1 times 10 to the negative 6. So that's going to be choice F or G. Then we're going to look at the omega, or the resistance. Again, just find that symbol. You don't even have to know what it means. And so our fastest, shortest time is 0.25. That's not one of our choices. We have 0.3 and 1. So you know 1 is going to be higher, 0.3 is less. So F is your choice. Question 19, your first read through. Do the experiments support this hypothesis? So let's break it down. Consider the following hypothesis. In a circuit arranged as in figure 1, a capacity and a constant resistance. As capacity increases, so find capacitance, the time required to reach the given voltage also increases. So as capacitance goes up, does the time also go up? And the answer is yes. We see the direct relationship there. And then choice A and B, is this experiment 1 or experiment 2? It's experiment 2. So your answer has to be B.